Okay, diagram 1 shows a bullet being shot out, okay, and then dia cakap di sini principle of conservation of momentum. I think this one is pretty self-explanatory. Principle of conservation of momentum, it's obviously before and after. Total momentum is the keyword, okay, that you don't want to lose for this. Okay, so the principle of conservation of momentum says that the total momentum, okay, I think this is one of the keywords that a lot of people seem to miss out. The total momentum before and after. Okay, before and after collision. Oh no. Berapa sudah hari saya tidak menulis? Sorry. Before and after collision. Okay, however you spell collision lah, okay, just ignore me. Okay, before and after collision, okay, is the same. Okay, but there is a condition for this. Okay, if there is no external force. Kalau tiada luar yang bertindak. Okay, if there's no external force, the total momentum before and after is the same. I was talking to a student, and he was asking me about, how do we memorize this principle? I think a lot of principles, if you think about it, a lot of principles, there is a relationship that's involved, and usually there is a condition. Okay, so like for example, the principle of conservation of momentum, okay, the principle of conservation of momentum is this one is equal to this one, tapi syaratnya is the external force is not there. So I think a good way to remember a lot of laws, a lot of principles, is you need to remember that there is a relationship happening over there, but the relationship has a condition. Dia ada syarat tertentu, okay, yang mesti dipenuhi. So if you remember that as a to write the definition, okay, then you have in mind, okay, saya mesti tulis dulu dia punya relationship, and then saya mesti tulis dia punya condition. Not all relationships have conditions, but yeah, generally they kind of is a lot lah. For example, Hooke's law. Okay, Hooke's law is the force is directly proportional to the extension. Tetapi there's a syarat. Syaratnya is you don't exceed the elastic limit. Okay, so that's a good way, I think, kind of like a good hint to remember how to remember principles, how to remember laws, things like that lah. Okay, state the type of collision involved here since they're together at the beginning and then they split apart. Okay, so this will be an explosion lah. Okay, atau letupan. Remember the other two are elastic collision and inelastic collision. Okay, pelanggaran kenyal, pelanggaran tidak kenyal. Elastic collision is lepas dia berlanggar, they split. Okay, either they split like this or they langgar and then they still separate lah. Yang penting selepas pelanggaran they separate. That's elastic. Kalau inelastic, lepas dia berlanggar, after they collide, they travel together. Okay, a horrendous car crash is an example of that lah. Okay, lepas dia berlanggarkan terus dia skid sama-sama. Okay, that's a norm. That's an inelastic collision. Okay, but kalau dalam case ini dia bermula bersama-sama dahulu and then they split apart, usually in different directions. This is what we call explosion. Okay, the condition for this to happen. Okay, I kind of don't like this question because it's a little bit strange. State the condition of the cannon when the bullet is ejected. When you say the condition of the cannon is fine. That's obviously not the question lah. Okay, they're not asking you how you think the cannon is feeling, right? It's not about that. Okay, but I think what it's asking is what happens to the cannon after the bullet is ejected. Okay, so of course the main key word here is the cannon recoils to the opposite direction. Okay, so the key word here being recoil, dia akan tersentak, okay, tersentak ke belakang lah. I like to say the opposite direction because, of course, this one you can say ke belakang. I think it's not a problem. Okay, pun boleh. But the general answer I will give is it will recoil ke arah yang bertentangan lah. If the bullet is going forward, the meriam, the cannon is going backwards. Okay, what happens to the total momentum? Okay, after the shot. Remember, this is a question of what happens. Generally, what happens has three kinds of answers: increase, decrease, or unchanged. Since this is total momentum, okay, we know that total momentum must always be equal before and after the collision. So After the shot, what happens to the total momentum is that it remains unchanged. Okay, be very careful about this. I was looking at the marking scheme and I thought it's pretty interesting. If you answer unchanged, you will get the mark. If you answer the total momentum is unchanged, okay, you will still get the mark. But if you say the momentum, and this can happen because, you know, sometimes in the exam, kamu tahu itu jawapan sebenarnya, but you're in a rush to write it out. So you may forget this. If you write momentum is unchanged, okay, this is wrong because that's not what the question is asking. Itu bukan pertanyaan soalan. Soalan tanya jumlah momentum. The question is asking for total momentum, not just the momentum. Okay, so be very careful about this. Yes, I know exam got all these funny rules that we have to follow in order to get a good grade. Okay, so but things like this, you need to be careful. Okay, if the question asks for this, give them the answer according to the question. Okay, and that's why you have 2.5 hours. It's not for you to sleep, okay? It's for you to check the paper again and again. Check terutamanya jawapan yang kamu betul, pastikan yang that you know you don't tulis benda yang salah konsep. Okay, I'm not trying to scare you. I'm very sure that ini semua ada sudah dalam kepala kamu ini sebenarnya. Okay, it's just that when it comes to exam, you know, things get a little bit more real during the exam lah. Okay, and then you find that suddenly you're 2 times more nervous than exam biasa, and that is totally normal. Okay, teacher can say the total momentum 0. Yes, can. Okay, you can say the total momentum is 0. I don't think it's an issue. Boleh juga. Okay, yang penting jangan tulis momentum saja. Okay, right? Total momentum. Okay, thank you for the question. It's a good question. Okay, diagram 2 shows a deflection tube emitting electrons when the switch is on. We've answered a question similar to this. Okay, so I think we're just going to go for this. Name the process that emission of electrons. Okay, kalau ada pembebasan elektron, there are only 2 possibilities. Thermionic emission, photoelectric effect. Case yang begini, you know thermionic emission sebab ada battery. Kalau photoelectric effect, dia mesti ada cahaya yang bersinar. Obviously, this one doesn't happen in photoelectric effect lah. Okay, so this is thermionic emission. Okay, reminding you once again, the definition for thermionic emission, okay, pancaran thermion and photoelectric effect, the definition is very similar. So it's very easy to remember. I think it's a good definition to memorize because they're sangat similar. Okay, so you just have to remember this only. Okay, when the electrons are emitted in the deflection tube, the current flows in 10 seconds. Okay, so you have time over here, and this is the current. Okay, so if you look at the formula list, okay, because the question asks for the total charge, kan? Okay, the formula list, even if you don't know lah, kan, what is this one? If you take the formula list, kan, hanya satu formula saja yang melibatkan I and T. So you can kind of guess that, oh, okay, I guess total charge is, well, it has to be Q lah, kan? Okay, so you will get Q equals to I times T. Okay, I is 0.05, Q is, T is 10, so your answer will be 0.5 coulombs. Okay, remember that the total charge, okay, unit for total charge is coulomb, C-O-U-L-O-M-B. Okay, it's, yeah, sometimes I recently learned this from somebody. Dia cakapkan kau tulis dulu semua simbol-simbol yang berkaitan, baru kau pergi cari itu formula di depan. Sometimes dia akan kena. Okay, I think that's a good one. Actually, it's a good tip lah. Okay, that I heard from another teacher. Tapi yang penting kau kena you have to remember lah the symbol. Okay, you cannot just luan put whatever symbol you want. You cannot. Okay, it has to be the correct symbol lah. Okay, like in this case, ada I, ada T. Okay, some people will be like, what is the symbol for the total charge? Pergi carilah di depan. Okay, that's what the formula list is for. Okay, sketch the electron flow if the value is increased to 5,000 volts. Now, if the value is increased to 5,000 volts, means there is a much bigger potential difference over here. Means its ability to pull the electrons is much stronger. Okay, and this is where we need to be very careful. If the voltage increases, make sure that, okay, starting point is the same. Make sure that you draw the deflection nearer because dia lebih cepat tertarik. kan sebab dia punya voltan lebih tinggi, kan dia lebih cepat tertarik. Two things to point out here. Number one, try as much as possible to start from the same place. Number two, make sure that your deflection touches the plate. Okay, jangan juga kamu, sudahlah kau tidak start dari tempat yang sama kan, terus kau kasih gantung di udara begitu. This one, if I were the examiner, I would obviously mark this wrong. Okay, because number one, the number one thing that is the most important is it didn't even touch the plate. It didn't even touch the plate. That one is definitely out lah. But the second thing that I think that we should take note is that the deflection starts from the same point. So my suggestion to you, okay, don't take this lightly. It's something that actually can be done. Okay, it's not that difficult. Make sure you start on the same place and deflect all the way to the plate. Okay, don't have to draw arrow. I don't think it matters because here also got no arrow, so tidak payah. But the most important thing is make sure it touches the plate. Okay, again, exam rules. We have all these funny rules that are there to make sure that you are careful. Okay, it's not to trap you or mau kasih trick kamu. No, it's just to make sure that you are careful and that you are conceptually correct. Okay, itu yang lebih penting. Okay, give one reason for this. Okay, so the reason why the deflection is nearer, okay, obviously is because the electric field, okay, the electric field strength, okay, kekuatan medan elektrik has increased. Okay, what you cannot say is the voltage increase. Sebab itu sudah dibagi dalam soalan. Okay, kau tidak boleh cakap, oh, sebabnya adalah sebab voltan sudah naik. Itu dalam soalan sudah. Okay, that's in the question. So you cannot give that answer for your reason. So think about, ask yourself why. Okay, jadi kenapa lah kalau itu voltan naik? Then ask yourself the next step. Okay, especially when it comes to giving the explanation. Remember, ask yourself again and again. Jadi lepas ni apa? Jadi lepas ni apa? Try to think of it. Okay, you can do this. Don't worry about this. Okay, diagram 3.1, 3.2 show a gas with a fixed mass heated in a cylinder. Okay, Borden gauge readings are fixed. Okay, keyword number one is fixed mass. Ini kita mesti tahu. Kalau kita nampak sudah fixed mass kan, this is gas law. Okay, so our job now is to figure out which gas law. Sama ada dia Gilus-Up, Charles or Boyle. Okay, but the moment you see fixed mass of gas, okay, gas berjisim, astaga, gas berjisim tetap, bahkan ini memang hukum gas sudah, tak payah fikir benda lain. Okay, it's the only time it appears. So, then we take a look at the situation lah. Okay, first of all, kamu ada tolok tekanan. You're talking about pressure, okay, and then you're looking at the thermometer change. Oh, sorry. And then there's the volume. Apa yang saya buat ni? Sorry. Notice that the pressure remains the same. Okay. Pressure remains the same. Teacher, if more attracted to the anodes, more attracted to the anode, cannot. Okay. It's not about more. I think you're talking about this, right? It's not about more attracted. Unless you say a bigger force of attraction, I will accept. Yeah. Bigger force of attraction, daya tarikan yang lebih kuat. Itu okay. Daya tarikan elektrik yang lebih kuat is a better answer. Tapi more attracted kan, the physics is not there lah. Okay, more attractive force, itu boleh. Okay, more attracted saja 50-50 lah. Saya susah mau cakap kalau dia boleh diterima atau tidak. Okay. Thank you for the question, Mr. or Miss Free Wi-Fi. Okay, we have all these people with these funny names, but anyway, thank you for the question. Okay, sorry, coming back to this. So notice that the pressure is the same. Okay, we go back to our triangle. Okay, P, V, and T. So since pressure is the same, I'm going to highlight this one. That means the relationship, what am I doing? Okay, that means the relationship is between V and T. Okay, if it's between V and T, I hope you know this by now. This is Charles' law. Okay, yang paling penting, nama dia tidak boleh salah dieja. C-H-A-R-L-E-S. Okay, dia bukan C-H-O-L or C-H-A-L-S. Charles. Okay, it doesn't work that way, people. Nama orang, kita mesti hormati orang tersebut. Okay, hukum Charles law, make sure that The name of the person tidak salah. Okay, based on the kinetic theory of matter, if you have followed me in the previous classes, you know that I will keep saying this again and again. Okay, explain the relationship between temperature and volume. Obviously, in this case, kita panaskan lah. So, temperature yang mesti berubah, baru volume dia berubah. So, think about this. Kalau temperature, apa yang kita cakap? Kita cakap temperature pasal kinetic energy, tenaga kinetik. And then the volume is it fills up the space. Okay, it fills the space. Sorry, dia mengisi ruang. Okay, dia mengisi ruang supaya tekanan gas adalah malar. Okay, so that the gas pressure is constant. Okay, so always start with this. When the temperature increase, okay, when the temperature increases. Okay, sorry, I've been typing for the past week, so obviously I have forgotten how to write. When the temperature increases, okay, the kinetic energy, okay, of gas molecules increases. Okay, so that's the first point lah. Okay, when you talk about temperature, talk about what happens to the gas molecules under high temperature. Okay, then Charles' law is temperature volume. So we need to talk about the volume for the second point. Okay, the gas molecules is, fill the space. Okay, mengisi ruang lah is the word. Okay, fill the space in the container. Okay, to to increase the volume. Sorry, to increase the volume. Okay, so that the pressure remains constant. Okay, so they fill up the space, so they increase the amount of space lah. Okay, so that the gas pressure remains constant, because that's what Charles' law is about. Of all the three laws, Boyle's law, Boyle's law, Charles' law, and Gay-Lussac, okay, I've covered each law. Apparently, I've covered each law punya kinetic theory of gas explanation from the three papers that we have done, from the few papers that we have done. Okay, so please go and look back at the kinetic theory of matter, okay, atau kinetic theory of gas, explanation for Charles, explanation for Boyle's, explanation for Gay-Lussac. So is volume expands in order to maintain pressure to increase the rate? Yeah, can. Same thing. Okay, the volume expands because the gas molecules fill the space. Okay, whatever it is, make sure that, okay, kinetic theory of gas actually is quite easy to remember, but sometimes it can get very confusing to explain. Just remember that in each sentence, okay, if it's a 2-mark question, then you know you have to provide 2 points. In each point, talk about what happens or what is going on with the gas molecules. Okay, then you know that you're on the right track. Kamu kena bercakap pasal tu molecule gas. Okay, kalau kamu bercakap pasal teori kinetik jirim, kan, kau kena cakap tentang apa yang sedang berlaku kepada gas molecule. Okay, pada ketika kamu kasih panaskan, pada ketika macam mana dia punya tekanan bertambah, how does the pressure increase? Okay, what is the kaitan with the gas molecules? When you understand the relationship, macam mana kamu pusing kamu punya jawapan pun bahkan tidak boleh lari jauh. Okay, so my advice to you is aim to understand how the physical quantity, macam mana, apa kaitannya suhu, what's the relationship between temperature and what's happening in the gas molecules, the volume, what's happening in the gas molecules, the pressure, what's happening in the gas molecules. When you understand what's happening, okay, then no matter how you explain it, it's fine one. Okay, dia boleh tunggang terbalik lah, tapi if the points are there, you will get the point. Okay, the easiest to remember, because I think we say it so many times, tapi saya rasa paling senang untuk kita ingat, is always temperature and pressure. Temperature, kinetic theory. Kinetic energy. Kan, tinggi temperature means banyak kinetic energy. Molekul bergerak dengan cepat. Kalau, if you're talking about pressure, is collision between the gas molecule and the walls of container. High pressure means banyak pelanggaran. Low pressure means sikit pelanggaran. Okay, volume is a little bit complicated. I understand volume is a little bit complicated, especially Charles' law. It's a little bit more complicated to explain because you have to talk about the increasing of volume. Okay, the reason why it expands, the reason why the volume expands is because the gas molecules are filling the space. Okay, but keeping the pressure constant. Okay, so try to remember the relationship, and hopefully this question comes out, so at least you have a shot at getting the marks lah. Okay, the air in the cylinder has a volume of 0.3 meters cubed. Okay, temperature 27 and 80. Okay, and of course, the reason why I always will highlight this is because whenever you are doing gas law calculation questions, temperature must be in Kelvin. Okay, if this is your first time joining us, well, I don't always meleter macam ni lah, tapi this is like so near to the exam. Okay, so saya kena meleter yang banyak kali sudah saya kasih tahu ni. So yeah, it's going to happen again and again lah. Okay, so please don't be annoyed by all this leteran lah. Okay. So yes, gas law. Okay, make sure that the temperature change to Kelvin. And how do you change to Kelvin? You plus with 273. What you're gonna get is 0.3. Sorry. Oh no, what's happening? Okay, 0.3 over 27 plus 273. Okay, equals to the second volume, which I don't know. Okay, over 27, 80 plus 273. Okay, do the switch around, you should get V equals to 0.353 meters cubed. Okay, we hold to the standard of 3 decimal places. Okay, not a problem. How do you know the unit is meter cube? Because the original unit is meter cube. Be very careful about this. Kadang-kadang soalan dia akan bagi centimeter cube, kau ikut saja. Teacher, which one is your favorite law? I just read this question. My favorite law. Well, I don't know. This is a very random question that has to do. I think my favorite law is Guy Lussac's law lah. Not because his name is spelled as Gay Lussac, but I think Guy Lussac's law is kind of like, yeah, it explains a lot of things like pressure and temperature. Yeah, correct, pressure and temperature. Don't you think that the more pressured you are, the hotter you become? Like SPM pressure, right? Terus kau rasa kau macam mau sakit sudah. Yeah, anyway. All these lame physics jokes lah. Jangan. Please don't. You're welcome. Okay. Number 4. Okay, diagram 4.1 showing the arrangement of apparatus to study the behavior of charged particles in an electric field. Okay. Electric field, well, I think this is the one with the weird. Okay. So what is meant by electric field strength? Okay, so electric field strength is a region where a charge experiences an electric force. Okay, so it's electric field. Sorry, electric field strength, not electric field. Electric field is the region. If it's electric field is the electric force. Acting on a unit charge. Sorry, my mistake. Electric force acting on a unit charge. Yes. Okay. Electric force acting on a unit force. Okay. The good thing about electric field strength, okay, and magnetic field strength, is that I guess the keywords are pretty similar. If it's magnetic field strength, okay, then it's a magnetic force acting on an object, not a charge. Okay, charge is specifically electric force. But electric field strength is the electrical force acting on a unit charge. But the magnetic field strength, okay, kekuatan medan magnet, okay, is daya magnet yang bertindak ke atas satu object, not unit charge, okay, an object. if you're specifically talking about magnetic field charge lah. Magnetic field strength. Okay, it's a magnetic force acting on an object. Okay, almost similar. Okay, since we are on this topic, we also need to talk about electric field lah. Sebab ini pun pernah keluar. Kalau electric field saja is satu kawasan. Okay, and a region. Oh man. Okay lah, let's go down this rabbit hole lah. Okay, electric field is a region where a unit charge, okay, experiences an electric force. Okay, kalau magnetic field is almost the same lah. Okay, I think you can kind of conclude from whatever that I've been discussing so far. Magnetic field is a region, okay, where an object, okay, experiences a magnetic force. Okay, so we kind of see that actually dia punya keyword bahkan hampir sama bah ini. Okay, medan elektrik is satu kawasan di mana unit charge, okay, charge unit unit charge mengalami daya elektrik and experiences an electric force. Magnetic field is a region, we start with the same words, a region where an object, okay, sebab any object, any metallic object, ferromagnetic lah, okay, experiences a magnetic force. By that same logic, electric field strength is the electrical force acting on a unit charge. Magnetic field strength is the magnetic force acting on an object. Just remember, kalau magnet, object. Kalau electric, unit charge. Okay, unit charge is 1 coulomb lah. Okay, but unit charge lah. Okay, so these are all these definitions kan yang kamu cuba, like we try to pau kaliao lah, the similar definitions kan, we memorize one, should be able to memorize the rest. So we aim for this kind of definitions so that you have less to remember. Some definitions I know, some definitions are like, the worst thing in the world. For example, Newton's universal law of gravitation is such a mindless, it's not mindless lah, but it's such a difficult definition to remember. Newton's universal law of gravitation. The other one is Kepler's third law. Okay, honestly, please don't ask me what is my least favorite definition lah, but these two are tough lah. Okay, it's tough because tiada satu benda yang sama pun. Gas law also easier to remember. Okay, but these two are memanglah sangat disukai. Okay, based on diagram 4.1, what will happen to the candle flame when the extra high tension voltage is turned on? Okay, so the keywords over here is number 1, when the EHT is turned on, okay, the candle flame will ionize the air. This is a very important word. Okay, the ionization of air happens here. We can look at the formula to find the definition. Yes, you can. Okay. This one, this one, I think I must clarify this properly. Okay. Kalau worst case scenario lah, okay, worst case scenario, okay, if you cannot remember the definition, okay, like kau tengok pun macam mana pun kan kau tidak ingat sudah dia punya definition, okay, the last hope that you have is just write the formula in the definition, but write down everything, as in, contoh lah, okay, if let's say Newton's universal law of gravitation, G m1 m2 over r squared. Okay, write down there, force is what, F is what, G is what, M is what, R is what, begitu. Okay, this is, honestly, I think this is very unlikely lah. Okay, unlikely to get you that mark, but you never know. Okay, you never know kalau tiba-tiba pada tahun ini, itu penanda kertas itu kan semua baik hati. Okay. Semua baik hati macam kamu punya penanda kertas bahasa Melayu kan, yang suruh kamu bagi peribahasa yang bertentangan. Okay, you never know lah. Okay, you never know. If that happens, okay, then at least you gave it a shot and you may get the mark. Okay, But I think what Muhammad Farish is asking is mungkin daripada formula ini, you are right. From the formula, actually you can write down the relationship lah for Newton's universal law of gravitation. Yes, you can. Okay, you can look at the formula to find the definition. But I'm speaking to the people yang memang struggle dengan definition. Dengan definisi, dengan prinsip, dengan law, bahkan dengan hukum. Kalau betul-betul kau tidak dapat, you know, the best thing to do is cuba saja, don't leave any space empty. Biarlah kau menulis itu formula dengan harapan yang formula itu ada markah. Okay, then whatever happens, happens. Yang penting kau sudah cuba. Okay, the worst thing you can do for yourself is, saya tidak tahu, jadi saya tidak jawab. Jangan pergi, don't go down that road. Even if you don't know, okay, you just don't know at that moment. Mana tahulah kan, 2 minutes before the exam kan, tiba-tiba kau ingat. That can happen. Okay, so never be of the mindset that, oh, kalau saya tidak tahu, jadi saya tidak jawab lah. You just got to try. Okay, you have to give it all you got. This is your last shot. Okay, what else do you have to lose? You have nothing to lose. Okay, just give it your shot and you never know. Okay, it may be helpful. Yeah, right. It's all or nothing. Wow. Gosh. Okay, sorry. Coming back to this, most important thing you need to talk about is that it ionizes the air. Okay, and when it ionizes the air, the positive and the negative plates will split lah. Sorry, the positive and the negative charges will split. Okay, and then it will form, and the candle flames will spread out. Okay, so first point, when this one is turned on, okay, when the EHT is turned on, okay, first of all, talk about what will happen lah, then you explain why. Okay, what will happen is the candle flame, okay, will spread out. Okay, dia akan tersebar. This is a 3-mark question, so which is why I think it's very weird lah. But I'm gonna, okay, saya akan bincang soalan ini seperti dia adalah soalan 4 markah. Okay, because I think it makes more sense if it is a 4-mark question, but I'll give you the full explanation. So the first point you could talk about is, apa yang terjadi bila kamu on, itu nyalaan akan tersebar. Okay, so the reason for this, okay, sebab kenapa ini berlaku, okay, is because the heat, okay, the heat ionizes the air. Okay, and the heat ionizes the air. Sorry, when the heat ionizes the air, okay, it produces positive and negative ions. Okay, producing positive and negative ions. Okay, so then what happens is the positive ions, okay, will be attracted to the negative plate. Okay, yang positif itu akan tertarik kepada the negative plate. Oh dear, okay, negative plate. Positive ions will be attracted to the negative plate. Okay, and vice versa lah. Kalau kau mau tulis juga, you also can write vice versa. And negative ions will be attracted to the positive plate lah. Okay, tapi saya malas mau tulis banyak-banyak. Okay, and vice versa. Okay, so this is the explanation for the first thing that happens. The first observation is that the flame will terpisah menjadi dua. It will spread out lah. Okay, the question we need to ask is, how does it spread out? Which is the second thing that happens. Okay, you will find that the flame, okay, spreads bigger towards the negative plate. Dia akan menjadi lebih besar, okay, towards the negative plate. Okay, and the reason for this, okay, is because the positive ions have bigger mass, okay, than negative ions. Okay, that's why the flame spreads bigger towards the negative plate, because it's, you know, it's heavier lah. Okay, so the spread out will be much more. So, yes, I know obviously this is a very strange question to just give 3 marks for, because, in your textbook, the explanation is pretty long. And usually for this question, it is a 4-mark question. But I think what is important for us, kalau kita mau hafal ini, yang warna merah saya tulis di sini, the red color is the observation. The first observation is the flame dia terpisah. Sorry, dia akan tersebar. Okay, the flame spreads out. Okay, the second observation is you notice that towards the negative plate, the spread is bigger. Lebih tersebar ke arah plate negative. The words in purple are the explanations for the words in red. Kenapa nyalaan tersebar? Because of the ionization of the air. And so the ions, there will be 2 separate ions, each attracted to a separate plate. Okay. Why is it that the flame is bigger on the negative side? Because the attraction of the positive ions is much bigger, because they have a bigger mass. Okay, so when you structure it that way, then it becomes easier to explain. Okay, as a general rule, okay, this is not, ini bukan like a super tip lah, but a general rule, kalau soalan explanation, start with the observation. Bagi tahu dulu apa yang kamu nampak. Okay, sometimes lah, okay, dalam case ni, bagi tahu dulu apa yang kamu nampak and then explain why that happens. Okay, as a general rule, this can be a structure for you. What is the observation? Explain the observation. Okay, explain questions, banyak variation lah. There are a lot of variations. This is one of them. I think this is the easier one because dia suruh kamu nyatakan apa yang berlaku dan jelaskan. I think that helps us to structure it a lot better. Okay, so I'll leave this here. You can screenshot it if you want, but we're going to move on. Okay, so sketch the shape of the candle flame. Okay, so as I said just now, this is the negative plate and this is the positive plate. So most important thing is, no matter how pretty or this one, instead of ions, can I say proton and neutron? No, not proton and neutron, proton and electron. But you shouldn't actually be saying proton and electron. You should be saying positive. Actually, you know what? You cannot say positive. You cannot say proton and neutron. You should say positive ions and negative ions. Sebab proton and neutron, they are subatomic particles, bukan ion itu sendiri. Protons are not necessarily ions, right? Oh no. Okay. No, yeah, so macam saya cakap tadi, you should say ion positive, ion negative. Sebab proton is bercharge positive, tapi proton is not necessarily an ion. Okay, definitely not electron. If I use cations and anions, sure. I think cations and anions are better than protons and neutrons. I think this is more important. Onion is obviously out. Thank you, Mr. Bro Gamer. Oh no. Okay, so anyway, coming back to this, obviously the spread is much bigger over here and much smaller over here. Yang paling penting, no matter how nicely or ugly you draw it, yang paling penting di sebelah negatif ini dia mesti lebih besar, dia punya nyalaan api. Okay, di sebelah positif dia lebih kecil. Okay, when I was preparing for this, I noticed that actually the question didn't ask for it, but I was wondering why it was 2 marks. At first, I thought the 2 marks is, okay, bigger on the negative, 1 mark, smaller on the positive, 1 mark. Tapi rupa-rupanya, when I was preparing for this, they said that you should show the ions, okay, that are involved. And then over here is negative, 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 negative. 5 enough lah. You can, I mean, sure, you can fill the entire space lah if you want, ayo. Okay, but the idea is show the charges that are involved. Okay, and I realized that the reason why this was in the answer is because in your textbook, okay, the drawing is also like this. Okay, they draw the flame out and then they also draw the charges on it. Okay, so I think this is a pro tip lah, I guess, if you want to call it a pro tip lah. Okay, so positive ions and negative ions. Okay, be very careful. Okay, 2 coulomb charge, okay, is placed in an electric field and experiences an electric force of 0.0032 kilonewtons. It's pretty interesting, kilonewtons. Calculate the strength of the electric field. Okay, so let's go with this. 2 coulomb is Q. This one is F. Okay, because it's force lah. Okay, obviously force is F. The reason one side is bigger because the positive ion is not just larger but it's heavier. Actually, the heavier is more important. Sure, it can be larger lah, but the positive ions are generally heavier. Strength electric field, if we go back to the formula list, it's there, everybody. It's there. Okay, it's right here. Okay, E equals to F over Q. Strength for the electric field probably refers to E lah. Okay, however, the trick question over here is the usage of newtons and kilonewtons. Okay, E equals to F over Q. So in order for us to use the electric field strength, okay, it has to be newtons. Electric field strength is newtons per coulomb. Okay, so you have to change this to newtons. Just darab 1000 saja. Okay, 1, 2, 3. So you get 3.2 over 2. Okay, which is about 1.6 Newton coulombs. Okay, let's move on to number 5, number 7. What is 7? Okay, number 5. Kepler's second law, law of areas. Okay, a line that connects blah 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 sweeps equal this one at equal times. Okay, so a line that connects the planet and the sun will sweep out equal areas at equal times. Yeah, okay. Yeah, sweep out equal areas at equal times. Okay. Let me just add one extra word here. A line that connects the planet in orbit. Okay, and the sun. So that line will sweep out equal areas at equal times. Okay, when we come to question number 5, please remember question number 5 and number 6 is generally the compare and the relate question. So the first comparison is the arc length of AB and CD. Obviously, AB has a bigger arc length than CD. Okay, just to remind you, start your answer with the thing that you're comparing. Make it a good practice. AB is bigger than CD. Okay, kalau kamu menulis dalam ayat penuh, this doesn't matter. But if you're going to use symbol, always start with whatever it is that you want to compare. Okay, it's actually not very necessary in section A, but you want to make it a habit so that you do the same thing in section C. Okay, so you don't forget. Okay, the area. Okay, the area will be AFB equals to C. Okay, CFD because of Kepler's second law. Okay, the area over here and the area over here is the same. Okay, so area AFB equals to area CFD. And therefore, the linear speed, okay, yang lebih dekat dengan matahari ini, okay, dia akan bergerak lebih cepat. Okay, because it's nearer to the sun lah. And also because it has to cover a much bigger distance. So, linear speed, okay, A to B is bigger than C to D. Oh no. A to B is bigger than C to D. Okay, is what our answer will be lah. Okay. Next. State the relationship between the arc length and the linear speed. Okay, if we notice this, A to B bigger, A to B bigger, so the relationship will be a directly proportional relationship. Okay, so I'm just going to write a symbol here. The bigger the arc length, the bigger the linear speed lah. I think it works both ways. You can write the linear speed first, you can write the arc length first. At this point, it's okay lah. Okay, name the force that acts on the planet when it is orbiting the sun. There are two possible answers for this. Of course, the general one is gravitational force. Okay, the other one that is possible because it's orbiting is a centripetal force, daya memusat. Okay, centripetal force. Okay, what you want to avoid, is kalau soalan minta namakan daya and you just write the word gravity. That one may be wrong. Okay, technically it's not wrong. Okay, technically it's not wrong. Okay, but you know, again, as I said before, exam have these weird rules. If they ask for a force, name the force. It doesn't hurt to write another extra 7 letters, lah. Okay, gravitational force. Just write it. Okay, try it, especially when you talk about this, we rarely use the word answer gravity lah nowadays. Nowadays we always call it a force. Okay, gravitational force. Okay, mark the direction of linear speed in diagram 5.2. You can think of it as the satellite is going this way or this way lah, doesn't matter. Okay, but what matters is that the direction of the linear speed must be tangential. Dia mesti tangent kepada orbit. Okay, tangential to the orbit. Okay, so yang boleh diterima if let's say, okay, I'm going to write this in the pink. Kalau let's say the satellite is orbiting this way, the answer for pink will be something like this. Okay, that will be one possible answer lah. Okay, I want to change color to green. If let's say a satellite is moving this way, daripada kau sajalah. Okay, if it's moving that way, then up to you lah. Because it's not telling us where it's moving, so you have to assume something. Okay, if it's moving this way, make sure it is tangential. Dia tangent kepada tempat itu. What you don't want to be writing, okay, what you don't want to be writing is kalau, okay, ini yang salah. Kalau dia bergerak ke sini, ini salah. Okay, that's like apa itu? Like satellite yang sudah kena buang pergi udara, jangan. Okay, so the pink color and the green color are probably the only answers that I will accept. The one in red is obviously very out lah. Okay, itu bukan tangential, so itu adalah something wrong lah. Okay, the satellite has flown off the air or something. Okay, so we don't want to do that. Okay, I want to send this reminder once again because this happened last year and you want to kind of avoid this. If the instruction in the question is not clear, okay, or if there is missing information and the information is very crucial. Like for example, this case lah. Okay, dia tidak bagi tahu dengan kamu itu satellite itu kan berpusing melawan jam atau mengikut arah jam. It's not telling you whether the satellite is going clockwise or counterclockwise. Okay, and sometimes some people they will start to raise their hand lah. They will say, "Ayah, how am I going to draw this answer? I don't know where the satellite is moving." Okay, wait first. Okay, sometimes the exam paper comes with what we call an errata, E-R-R-A-T-A. An errata is a document that the invigilator is supposed to tell you. Okay, itu pengawas peperiksaan itu kena bagi tahu kamu, okay, ada kesilapan dalam soalan ini, dia akan bagi tahu kamu untuk betulkan. So ask and see, is there a correction for this question? Okay. If there's a correction, yay, okay, puji Tuhan, selesai. But if there's no correction, okay, and then kalau macam, saya tidak tahu ni satellite pergi mana, okay, tolong jawab. Don't not answer, okay, please answer. It can be the pink, it can be the green. Obviously, you don't answer both lah kan, salah satu daripadanya cukup, okay. Tetapi the worst thing that you can do is, oh, this soalan kan ada mistake, jadi saya tidak payahlah jawab ni soalan. Cannot. Okay, it doesn't work that way. Especially if you know how to answer. Just choose one of the answers, okay, and be confident lah, okay, that is the correct answer. Okay, the worst thing you can do is kau tinggalkannya kosong sebab tiada pembetulan. Jadi maksudnya itu soalan salah. There's no such thing. Okay, you have to answer it anyway. Give the examiners something to mark. Otherwise, if you don't answer, dia akan assume that, oh, this student doesn't know anything. Terus sayang. Okay, so we don't want it to happen. Okay, calculation question. The satellite has reached outer space and is orbiting the Earth at an altitude h equals to 2. There's oh sorry, there's this very interesting prefix over here, big M, small m. Okay, is megameter. Okay, kind of like MB is megabyte, megabyte. Okay, so mega is times 10 to the power of 6 lah. Okay, is it a very weird unit? Sure, it is a very weird unit, but is it wrong? No, it's wrong. Dia bukan bermaksud kau tidak pernah dengar, bahkan maksudnya dia tidak pernah wujud. Okay, mega obviously, exists, so be careful about this lah. Okay, linear speed formula given in the beginning, V equals to gm over r square root. Okay, just remember that the mass is the Earth's mass. I think this is a very simple question, 6.67 times 10, 11, negative 11. The mass is 5.97 times 10 to the power 24. Okay, remember the R is the Earth's radius plus the altitude. Okay, so there's usually two things to plus here. 6.37 times 10 to the power 6 plus 2 times 10 to the power 6 because megameter. Okay, 2 megameter. The whole thing kau kasih square root. Okay, if your calculator is like mine, yang satu baris saja dia punya ni kan, please do it manually, do it one by one, unless you're very good at menekan calculator. Okay, but if you do everything correctly, you should get 6897.430824. Okay, meters per second. I do not generally, I do not recommend standard forming it, okay, or changing it to standard form. Generally, I don't recommend. Saya rasa kalau jawapan begini lebih baik daripada it can be 6.897 times 10 to the power of 3. Okay. You should listen to, because we have people from different school, I think you should always listen to your original teacher. Kalau cikgu kamu cakap kamu boleh bagi jawapan begini, bagilah jawapan begini. Tapi the rule remains the same. Okay, minimum 3 decimal places. Okay, especially kalau jawapan itu panjang menjela bahkan. Okay, minimum 3 decimal places, don't bundarkan to anything less than 3. Okay, but for two very important chapters, actually 3 lah, gravitation, what is this? Chapter 6, nuclear energy and quantum physics. These 3 chapters, saya sangat menggalakkan. If you are my student, I'm telling you this again and again. Okay, take the whole answer from the calculator, and you really just don't bother to bundarkan. But if you really want to bundarkan, minimum 3 decimal place. Don't go less than 3 decimal place. Okay, if you really want to bundarkan itulah. Okay, but for these 3 chapters especially, because all these small decimal places actually make a very big difference in the calculation. Okay, so make sure that you don't oversimplify the answer. Okay, question number 6. 2 processes over here, fission and fusion. Oh no, what's happening? Sorry. So soalan macam tangent tadi, garisan gravitational force mau lukis kah? Tidak perlu, dia tidak cakap kan? No need to write gravitational force. Itu ke arah tengah bahkan, yeah, but no need. Okay. One is fusion and this one is fusion. I think it's not so difficult. Everything is given here. State another name for nuclear energy. This is a very strange question, but okay, fine. Another name is called atomic energy. Okay, or you can say, in terms of definition, I'm not really sure whether they're asking for definition, but I guess if they are, okay, then you can say energy that is released during nuclear reactions. Okay, nuclear reactions can be decay, okay, radioactive decay, can be nuclear fission, can be nuclear fusion. Okay, all these are all nuclear reactions lah. Okay, tindak balas nuclear. So atomic energy or nuclear energy is energy that is released during nuclear reactions. Okay, I think this is the answer, but this is the definition lah. Okay, just to give you the complete this one. Okay, complete the equations. Ini adalah pengiraan. I'm just going to highlight. Sebelah atas, dia punya jumlah kiri dan kanan mesti sama. Okay, manakala sebelah bawah, dia punya jumlah kiri kanan pun mesti sama. Important thing to note is that ini adalah 3 darab 1 dan 3 darab 0 di atas. Okay, so if we do everything correctly, over here should be 56 and over here should be 4. Okay, this is a pretty simple calculation. Okay, compare the energy released. Okay, right, let's go to this. So in terms of the energy, I think you can do your own comparison over here. Obviously, negative 11 is bigger than negative 12. Okay, so energy released. Okay, X is bigger than Y. Oh, sorry, what's it called? Oh, reaction X, sure. Okay, reaction X is bigger than reaction Y. Mass defect. Okay, in terms of mass defect, you will probably need to count this. Okay, but this one, the mass defect is 0.18606. Yang besar tolak yang kecil. Okay, you get 0.18606, and then over here is 0.018. Okay, so it's a much bigger, very big difference lah. Okay, reaction X is bigger than reaction Y. Okay, the number of neutrons, tengok dari sini, this is 3 and this is only 1 neutron, so the same thing. Okay, number of neutrons, reaction X is bigger than reaction Y. Okay, this is a very simple comparison. Maybe the only challenging one is mass defect. Tapi yang penting, sebelum dan selepas kau kasih tolak saja. Okay, then you get the apa itu cacat jisim. Okay, yeah, cacat jisim. Okay, dalam bahasa Melayu there are 2 words. Cacat jisim, the other one is susutan jisim. Tapi susutan itu saya rasa bahasa yang lama lah. Okay, we usually don't say this anymore. Okay, using our answer in 6C, relate the energy and the mass defect. So energy di sini, mass defect di sini, the direction of the symbol is the same. Therefore, the bigger the energy, the bigger the mass defect. Cuma, remember that in this case, the mass defect must come here first. The bigger the mass defect. Sebab mass defect yang mempengaruhi the energy, the bigger the energy. Okay, saya tahu soalan dia minta tenaga dulu baru cacat jisim. Okay, but remember every relationship must make sense. Okay, kamu kena tanya diri sendiri mana yang penyebab, which is the cause and which is the effect. Be very careful about this. Okay, the reaction, obviously this is nuclear, apa itu, fission. Okay, and reaction Y is nuclear fusion. Okay, I think this is okay lah, quite easy lah. Okay, not so bad. Okay, Pascal's principle, etc., etc. This hydraulic chair, we've seen a question similar to this. So I'm just going to go for this. The pressure exerted. Sorry. Pressure exerted on an enclosed fluid will be transmitted uniformly, okay, to all directions. Keyword is pressure, enclosed, transmitted uniformly directions. Cross-sectional area, etc., etc., etc. I think it's not difficult, this one. Multiplying factor. Okay, multiplying factor is either F2 over F1 or A2 over A1. Okay, any one of this is a multiplying factor. Since you're given the big and the small, this one, okay, so the multiplying factor will be 1224 divided by 96. Okay, this is a 1 mark question, so even the calculation doesn't matter. When you do this, you will get the answer 12.75. No, not Newton, sorry, 12.75. Okay, what you shouldn't be giving me is fraction. Okay, jangan juga kau bagi fraction. Multiplying factor has to be a number. Actually, very few calculation questions kan, dia punya jawapan akhir is fraction. Okay, because we are in the big leagues already. Okay, this is physics. It's no longer maths. maths form, form 3. So as much as possible, give your answers in decimal place. Okay, exerted 2124. So F1 over A1 equals to F2 over A2. Okay. Calculate the force that must be exerted on the small piston. Okay, so that's F1 lah. Okay, this is F2. I'm going to give this as A2, ini A1. Okay, sebab yang kecil is 1. So, does the unit important for this question? No, multiplying factor, there is no unit. Okay, dia berapa kali lebih besar saja. So there is no unit for multiplying factor. A few things are no unit. Multiplying factor. Apa itu yang pembesaran itu? Magnification, linear magnification. Ini tiada unit. Okay, what is the other one? Oh no, I just had it on my mind. Multiplying factor, linear. Index biasan, refractive index. Okay, refractive index got no unit. Okay, so these are the very few things that got no units lah. Okay, be very careful about this. Okay, sorry, coming back to this, kita mau cari F1. So 96, F2 is 2124, seperti diberi oleh soalan, over 1224. Do your calculation correctly, you should get 166.588 newtons. Okay, 166.588 newtons. I think this is not a difficult calculation question. Okay, 2 marks only. Okay, study the characteristic of 3 barber chairs. Okay, always look back to the purpose of this one. Sir, if I tell us divide 2124 with 12.75, that's even better. Actually, you are using the multiplying factor. It's totally not a problem at all. Okay. But what you should not be doing, sorry, since you're on this, you just reminded me, never calculate without showing your working. Okay, I have seen people, okay, they're, everything just totally didn't do, kan dia bagi jawapan akhir saja. Okay, this one will only give you 1 mark because 1 mark is for working. Please never be too smart until you don't show your working at all. Tak payahlah, no, everything got marked. Okay, so be as careful as you can. Okay, anyway, the purpose of our choice this time is you want to have a patient of greater mass and can last longer. So make sure that you don't give this as your answers. The type of liquid, obviously we want oil. Okay, and of course the multiplying factor, 45 divided by 2 is 22.5, this is 25. Oh, this is the worst. Okay, so we want a big multiplying factor. So we've spoken about this before. Why do we want oil? Our most easy answer to go to is incompressible. Okay, tidak boleh dimampat. You can also say low density, etc., etc. I would just go straight to the point and say, if I'm going to choose oil, it's incompressible. Okay, don't need to write too much. The multiplying factor should be big. Why am I writing besar? Big. Okay, so you can produce a bigger output force. Okay, generally, Pascal's principle, these kind of the answers that you want to give. Produce a big output force, produce, if it is a small piston, small area, is to produce big pressure. Okay, we always see this for Pascal's principle. It's a good idea to remember this. For the large piston, you want a big area to produce a big output force. But for the small piston, you want a small area to produce big pressure. Okay, differentiate between these two. Yang kecil itu menghasilkan tekanan yang besar. Yang besar itu menghasilkan daya output yang besar. Okay, daya output lah, the output force that is big. Okay, these are good things to remember because it's easy to remember and it comes as a set. Okay, remember this when you are mengulang kaji. What is that word in English? Revising. Okay, when you're revising for this. Okay, the most suitable, this one will be Q. Okay, sorry, let me continue on. Number 8, what is the meaning of the catapult field? The catapult field is a resultant magnetic field, bahkan, yeah. Resultant magnetic field. Oh dear. Resultant magnetic. Sorry. Resultant magnetic field due to the interaction, okay, between the magnetic field of a permanent magnet and a CCC, current carrying conductor. Okay, daya paduan magnetik yang terhasil apabila dua medan magnet berinteraksi. What is the two magnetic fields? The permanent magnetic field and the current carrying conductor. Okay, magnetic field, conductor pembawa arus. Okay, current carrying conductor, CCC lah. Okay, that is the definition for catapult field. Okay, draw a pattern resulting catapult field. Remember, catapult field is Fleming's left-hand rule. Okay, Fleming's left-hand rule is, this is the force. Okay, this is the final one that you want. This is the magnetic field, north to south. Okay, and this is the current. Remember that the X, okay, the X means that your current is going into the paper. Okay, and the dot is your current is coming out of the paper. So be very careful about where your third finger is pointing. Okay, so if it's X, point it into the third, point the third finger, sorry, point the third finger into the paper, do everything correctly, you should get an upwards force. Okay, I always find that, I mean, if you know how to do the long cut method, yang lukis dua bulatan, and then lepas tu carilah di mana dia, bertemu semua. Okay, you can do that. Okay, but I always find that it's easier for me to start by doing this. Okay, if the left side is going up, this side automatically is going down. No need to think twice about this. And because of that, the catapult, okay, yang berdekat-dekat is here. Okay, this is how it will look like. So you kind of want to, oh no, I don't know whether I can fit the third one here. Astaga. Okay, the third one, kasi muat sajalah. Okay, 3 lines I think is enough. Okay, and then this one above here is fine. Most important thing is the magnetic field goes from north to south. Okay, if you want to be like extra annoying, sure, you can write another one lah, same lah, sama juga itu. Tapi yang paling penting adalah I want to be able to see the curve on this side and the curve on this side. Seperti lastik. Okay, it's like a catapult, like a lastik. Itu yang saya mau tengok. Okay, that's the most important thing. In my experience, this takes a little while to get used to drawing. Okay, because of the catapult area lah, yang ini yang selalunya susah untuk dilukis. Okay, but the top lines can be curved, but very slightly. Sure, it just doesn't have to be too straight lah. I guess if you really want to be very technical, sure, you can also draw it like a little bit curved like this lah. I guess you can also. Okay, also not an issue, not a problem. But the main curve is the more important one. Okay, so this one should be slightly up and slightly down, like that. Okay, I will draw it like that lah. Okay, portable device can function as a screw or drill, rotate at low speed. So the reason why we want to do this is increase the rotation speed. So this is the answer that cannot be in your answer. Sorry, this is the statement that cannot be in your answer. Number of turns, I think if you know Faraday's law, you know Faraday's law enough, you know that there has to be more number of turns, okay? More number of turns means you will produce a bigger force. When you produce a bigger force, you increase the rotation speed, okay? Generally, that would be the design. Okay, shape of the magnet, we usually go for semicircular, okay, instead of a straight shape. More rate of cutting of magnetic flux. No, this is not a generator. It's not producing current. Okay, it's a good question. Yeah, curve here. So hold on. Let me answer Sharvin's question. Sharvin. Rate of cutting a magnetic flux is if you want to produce current. If you want to generate a current, then that will be the right answer. But in this one is you want to generate a force. Okay, think of your fan, think of your drill, anything that rotates. If you use an electric toothbrush, yang berpusing-pusing begitu, bahkan anything that involves rotation or movement, okay, the reason why we have to have more number turns is to produce a bigger force. Generally, a bigger force will mean that your fan spins faster lah. Okay, so that's what you want. Okay, so be very careful. Make sure that you know the difference between the catapult force question and the electromagnetic induction question. Electromagnetic induction is generator to generate electricity. Catapult field, like in this case, is force. You want to produce a movement. Okay, so it's a very, very important distinction to know lah. Okay, please know the difference between the two. Okay, yes, you can also say curve shape, whoever free Wi-Fi is. Okay, but the general answer for the reason will be to produce a radial magnetic field. Okay, this is the general answer. Those of you in All Saints, is generally the black book answer lah. Okay, we always look at this answer in this way. Okay, the type of coil, remember, if it is the type of coil, you can talk about the characteristics, you can talk about the material, but we know that the reason for all this is low resistance. Okay, low resistance means more current can flow. More current can flow means you will produce a bigger force. Okay, you will still get the same outcome, produce a bigger force. Okay, so you can talk about many things about the coil. It can be what are the low resistance wires? Okay, the wire will be copper wire. Okay, this is the general one. Copper wire is low resistance. Okay, you can talk, if you want to talk about thicker wire also can. You can also talk about longer wire, but longer wire already kena cakap pakan di sini. Ya, tidak boleh. So talk about thicker wire. Okay, thick wire. Okay, also can. The reason is still the same. Low resistance, produce a larger force, so that you get a bigger rotation speed. What you should not be writing in this answer is the statement in the question. Ini yang kau kena berhati-hati. Okay, sometimes we memorize the answers and we forget that ada pula jawapan saya dalam soalan. Be very careful about this. Okay, these are all the little things that we need to take care of. Okay, let's quickly go into this. Okay, because whenever it comes to this kind of class, kan banyak membebel-bebel. Jadi, let's try to finish all three. Okay, I think that I have identified which question I did that is so weird. Okay, I think it's this question. Okay. Okay, name the types of waves for electromagnetic waves. I think this is very, very standard. Okay, this is transverse waves. Okay, or it can also be a mechanical wave. Okay, I suppose you can say progressive lah. Okay, also can lah, the same thing. Okay, advantages of radio waves used in the remote control of a drone. Okay, so explain the advantages. So state two advantages and then explain why. The first advantage will be low frequency. Okay, radio waves have low frequency, and the reason for this is it has high wavelength. Okay, generally in a wave question, if you're going to write low frequency, you might as well just write the opposite at the same time, because it's going to be a second free point. Okay, if I were you. So what if it has a big wavelength? Kalau dia punya panjang gelombang besar, okay, so what? Most obviously is easy to diffract. Okay, and if it is easy to diffract, it will be easy to pass through. Pass over lah, not pass through lah. Pass over obstacles. Okay, without losing. Oh no, I shouldn't say this. Sorry. Easy to pass over obstacles. Okay, we just pass through obstacles because it's very easy to diffract. The reason why it's easy to diffract is because it has a high wavelength. The reason why it has a high wavelength is because it has low frequency. Okay, it's so general this answer, and I think it's pretty standard. You cannot go wrong with this. Okay, I think even if you work it the other way around also, I think it should be fine. Okay. Oh no, I've been sitting too long. I'm getting a cramp. Okay, when you talk about waves, you cannot run away from this one. Okay, remember that in the wave, okay, let me show you. Kalau wave dia punya formula bahkan, okay, this is the only one that is given. The one that is not given that you should remember is D equals to VT over 2. Okay, yang kita akan jawab sebentar lagi. But this formula is not given, okay, in the formula list. Ini adalah interference. Okay, this one only appears in interference. This one semua tempat kau akan pakai ni. Memang kau tidak boleh lari daripada formula pertama ini. Sebab this is the wave equation. Okay, tapi ini yang saya bimbang. Sebab ini sebenarnya datang daripada pun tiada, sorry. Ini formula, okay, is the one formula that is never given because it's too simple. Okay, it's actually velocity equals to distance over time. Okay, so be very careful. Please remember this. Perhaps when you get the question, the first thing you do is to write down all the formulas yang tidak diberi so that kau tidak lupa nanti in case the question comes up. Okay, here is the frequency, here is the time. Okay, the question then is YMS, M is milli, milli is 10 to the power negative 3. Okay, be very careful. This is V. So, the question is the depth. Obviously, they were asking for the depth. Okay, D equals to VT over 2. Okay, our V is 1.5. 1.5 times 10 to the power 3. Our time is 120 times 10 to the power negative 3. Why negative 3? Because milliseconds. Okay, divide by 2. Okay, jawapan ini adalah 90 meters. Okay, the wavelength, most of the time you will get V equals to F lambda. Okay, you want to find lambda bahkan. So 1.5 times 10 to the power 3 equals to 25,000 lambda. You will find lambda equals to 0.06 meters. Okay, this one, this is not difficult, but as I said, in the wave question, especially essay question yang melibatkan wave, kalau soalannya bukan soalan interference kan, most likely these two are the formulas that they will use. You cannot ask that much. Sebab sebenarnya tidak banyak soalan pengiraan in wave. Okay, but the most complicated one is interference. Okay, kalau interference kalau tahun ini, then yeah. Okay, but if this comes out this year, don't waste this chance. Just don't forget to write this formula. Okay, the moment you get the paper, write this formula down first because it's not given, okay, in the exam. Okay, 4 ships that can perform the seabed mapping process. Okay, number of transducer. Okay, just to this one, transducer is yang this one. Okay, transducer emits a wave signal. Okay, that's what a transducer does. Dia in dalam bahasa Melayu is pemancar gelombang. Wow. Okay, a transducer is alat pemancar gelombang. So the point of the transducer is to have more transducers lah. Because you have more transducers, okay, you can can emit. Okay, can emit more wave signals. Okay, let's just do a short check. Does this answer appear? Suitable for mapping the seabed. That's it. Okay. So can emit more wave signals. Okay, or you can also say more wave signals can be received. Okay, any one of this is fine. Okay, I want to talk about this. But this is the tough one. Okay, generally, okay, we want the frequency of the wave to be high. Okay, generally, we want the frequency of the wave to be high, and the general answer is to have high energy. Okay, can propagate, dia boleh merambat lebih jauh, further. Kenapa kita mau high energy? Sebab dia kena melalui air laut. And then lepas itu kembali. Kalau kita hantar a wave with a low frequency, okay, that becomes a problem because dia tidak cukup tenaga. Mungkin dia boleh pergi sana tapi dia tidak dapat pantul kembali. Okay, so we want it to propagate further. Okay, the main point of the high frequency wave. Okay, because it states the number of transistors, do we write more or number? More. Never write the number. Okay, write more. Yeah, never write the number. Okay, the reason why I'm doing all this circling is because, sorry, my students are used, well, I hope that my students are used to this, okay, that we just circle, but they already know that they shouldn't write number, you should write more. Very, very few cases you write number, okay, where it involves ratio, then maybe you can write number, but it really is on a case-by-case basis. Okay, but yes, don't write the number. Okay, because of the high frequency of the wave, okay, obviously we want a low frequency, low wavelength. This is very normal. High frequency means low wavelength, okay, and low wavelength, we still stick to the same reason, okay, easy to, low wavelength is, hold on. Let me just, yeah, low wavelength is difficult to diffract, okay, does not diffract, okay, easily. Means dia tidak senang tersebar. Okay, we don't want that to happen. Okay, I want to talk about this because this is this is kind of this one lah. Now, if you look at the pattern of our circles, you know that we want to choose T lah. Okay, that's obvious. You know that we want to choose T, and obviously the answer has to be ultrasonic wave because this is a transducer, this is a radar situation. Okay, in our syllabus and even in general text, we know that radar uses ultrasonic waves. The question then becomes, if you compare ultrasonic waves and microwaves, actually microwaves has a higher frequency, way higher frequency compared to ultrasonic. Ultrasonic is only about 20,000, 20,000 hertz. Okay, but wave, look at microwaves. Okay, 10 to the power of 8. Okay, so it's obviously way higher. So the question is, why are we choosing ultrasonic and not microwave? Since we want high frequency, high frequency. Okay, so the reason why we want ultrasonic, okay, this is a very specific reason. So I'm going to write it down here because it's so special that I need this amount of space. Okay, it can propagate further. Dia boleh merambat lebih jauh. Okay, with less diffraction. Or we call it scattering lah. Dia tidak terhumbang ambing ke sini sana. Okay, I checked this against I checked this against the internet. I did a search on this and I wanted to figure out, yeah, actually, it makes sense, we should use microwave because it's higher. But why don't radars use microwaves? Because the high energy of the microwaves, the extremely high energy of the microwaves makes it very unstable. Kan dia macam, it's like a kid on sugar lah, kalau dia banyak makan gula-gula kan terus dia jadi macam hyper something like that lah. Shouldn't more diffraction be better so that the waves can spread more? No, we want it to go back. We want, Shaban, we want the thing to go back here. We don't want it to go all over the place. Okay, so we want it to be focused, like, okay, please go and come back. Don't go and then pergi melencong sini dan sana, lepas tu baru kau balik. We don't want it to diffract. We want it to be as less diffracted as possible. Okay, so that it goes back to where it came from now. Okay, so yes, having said that, okay, for ultrasonic waves, okay, I know generally ultrasonic waves, I think for those of you in All Saints, even in the black book, it does say that ultrasonic wave is high frequency, high energy. But in this case, I wouldn't actually want you to give the answer for high frequency, high energy. Okay, because if you talk about high frequency, actually microwaves has high frequency. So ultrasonic is not. Ultrasonic high frequency tidak betul. That pairing is not correct. Okay, so I would actually encourage you, very specific case now, this case only, for ultrasonic waves, give the answer, it propagates further and it doesn't scatter a lot. Less scattering, less diffraction, harder to diffract. Okay, I think these are better answers than high frequency. I would actually avoid high frequency sebab dia akan bercanggah. Okay, if you want to say ultrasonic high frequency, microwave also high frequency word, so it doesn't match. Okay, so don't give the answer high frequency. Anyhow, once again, the 9th and the 10th mark, I'm not going to repeat this again, so T is our answer. Okay, right. Yes. Okay, number 10. A spring that is thick and has elastic properties compressed when the metal ball is pressed. 10.2b, show the maximum height. Okay, I think this Hooke's law, obviously. So what is the meaning of elasticity? Why don't they ask for Hooke's law? Okay, they ask for elasticity. Okay, so the elasticity is the ability. Okay, the ability of an object to return to its original shape and size after uh, the force acting on it is removed. Okay, keywords for this is ability, return, original shape and size after force removed. Okay, this will be the keyword for this. Shape and size, sorry. Why am I writing? Okay, based on diagram 10.1, sorry, I'm not sighing because of this. Based on diagram 10.1, explain how the metal ball can reach the maximum height. Okay, so when we talk about this, we need to talk about the change in energy. Okay, so when we press on it, you are giving it elastic potential energy. When we release it, okay, bila kita melepaskan itu spring, the elastic potential energy in the spring changes to kinetic energy in the ball, and then the ball akan naik. As the ball naik, okay, what is it going to gain? It's going to gain gravitational potential energy. Okay, gravitational potential energy. So the height of the gravitational potential energy will of course depend on the spring itself, the properties of the spring. All depends on the elastic potential energy. Okay, let me give you this answer in slightly different this one. Okay, the first one is, okay, when the force acts on the spring, okay, it gains elastic potential energy. Okay. The thick, because the spring is thick, okay, so there's a bigger elastic potential energy. Okay, so the thick spring increases. Okay, the spring constant. Thus, no lah, let's not use the word thus lah. Why do we use the word thus? Okay, and increases the elastic potential energy. Okay, so when we press it, we produce elastic potential energy, but because the spring is so thick, the elastic potential energy is much bigger. Okay, when the force is removed, the sorry, when the force is removed, the elastic potential energy changes to kinetic energy. Sorry, kinetic energy on the ball. Okay, kinetic energy pushes the ball up to change to gravitational potential energy. Okay, that's how you can reach the maximum height. Lah. The key thing is the maximum height is reached because of the thicker spring. Okay, thick spring means bigger elastic potential energy, therefore giving you a bigger gravitational potential energy, which gives you a bigger height. Okay, you can also write the formula if you want. EP equals to, what is this, half Fx, okay, or half Kx squared. Okay, kinetic energy is half mv squared. Okay, gravitational potential energy is mgh. So the H is over there to show you that the gravitational potential energy yang bermula daripada elastic potential energy, okay, yang menyumbang kepada the height, the maximum height of the ball. Let me move on. Okay, spring used in a pen. Okay, used in a pen and not in other things. So we want to talk about the length, etc., etc. For spring in pen, we want a much longer spring. Okay, we don't want such a short spring because we don't want it to be so tough. Okay, so the reason for the long spring, okay, usually long spring, the general one will be smaller spring constant lah. Okay, smaller spring constant, easy to compress. Okay, because the spring, when you push it down, okay, when you push the distance down, then the thing will come out lah, the thing. Okay, rate of rusting, I think generally rate of rusting is a pretty, like it's like a bonus answer lah. Okay, rate of rusting is low. Okay, so then usually our answer will be last longer lah. Okay, long lasting. Okay, doesn't rust easily, but rate of rusting, yeah, I think also can lah. Okay, doesn't rust easily. Okay, it sounds the same as rate of rusting, but I suppose it can be used lah. Okay, material, steel. Okay, obviously it's steel because of the same reason. Okay, long lasting, and it also doesn't rust easily. Make sure you don't write the answer, the rate of rusting is, sorry, for this one. Okay, for the material, you don't write down there on the left hand side. The material is steel, and then the reason is low rate of rusting. Tak boleh, because the low rate of rusting belongs on the left side. Okay, left side cannot repeat on the right side. Okay, the thickness of the wire is also low. Generally, low thickness will be small spring constant. We want this soft spring because it's pen. Okay, we don't want like the motorcycle punya spring on your pen. There's no point. Okay, small spring constant. Okay, so our obvious choice here will be U. Okay, moving on. Okay, calculate the spring constant. You are given, first of all, okay, let's just recap a couple of things. Most important formula here is F equals to Kx. Okay, this is like a must lah. Okay, I don't think it's gonna ask in this question, but in case there is, the potential energy, remember, is half Fx or half Kx squared. Either one of these lah. Okay, sorry. So F equals to Kx. Remember that because this one is in kg, okay, so we need to change it to newtons. Okay, so it's 10 times 9.81. Secondly, X is the extension or compression. Originally is 15. Lepas kau letak itu beban, dia menjadi 5. So the extension is 10 cm in this case. Okay, now everything in Hooke's law has to be changed to SI unit. So the 10 cm should be 0.1 meters. So your F is 10 times 9.81 equals to K times 0.1, which will give you K equals to 981 Newton meter negative 1. Okay, if you want to use the K as Newton per centimeter, it's also fine, but I generally like to tell my students, try to keep it to Newton per meter. Okay, but it's not wrong if you use it as Newton per centimeter. Okay, then you want to calculate the load of P. Okay, let's consider this. The load of P extension over here is 3 cm. Why? Because originally 15, dia menjadi 12. So the extension is 3 cm. Change it to meters, 0.03 meters. Okay, so same thing, F equals to Kx. Sorry, the answer for this is here. F equals to Kx. Our F we don't know. Okay, but our K we already know, 981. 981 darab 0.03, which will give you about 29.43 newtons. Tapi soalan minta the mass. So convert it back. Okay, so the mass is 29.43 divided by 9.81. Okay, which will give you exactly 3 kilograms. Okay, this is a pretty standard question for Hooke's law. The tricky part about this question is the different units there are. Okay, if this is a question that you can do, I would suggest that you do it. But if you can't, if you find that this too many units thing is this one, I think actually generally the wave question is easier, but I don't know. It depends on the person, I guess. Okay, right, let's move on to the last question, because the last question has the biggest number of answers. Okay, 11.1, show a refracted ray, etc., etc. What is the meaning of the critical angle? Is the angle that produces a 90-degree refraction. Okay, so critical angle is the incident angle. Incident angle in an optically dense medium. Optically dense medium that results in a 90-degree refracted angle or refractive angle, okay, in a less optically dense medium. Okay, this is a tough definition. Okay, yeah, you can't have it all. Okay, it's not all easy. Some of it is tough, but we hope that for your exam, yang definition yang senang keluar lah. I mean, okay. I think this comparison is not that difficult. Okay, let's just double check to make sure that there are 5 things. Since there are 5 marks, compare the critical angle. Next thing, compare the optical density. Next thing, the refractive index. Okay, so 3 comparisons, and then obviously 2 relationships. State the relationship between the frequency and relate the refractive index and the critical angle. Okay, in terms of critical angle, I think you can see this very clearly. This diagram has a bigger critical angle than this. And it's a very subtle difference. Actually, I had to look twice to see it. But yeah, in terms of the critical angle, okay, 11.1 is bigger than 11.2. Okay, please remember how to write it in the essay section. Okay, remember, start with the thing that you want to compare and then write the comparison. Okay, optical density. Okay, before we go to optical density, let's talk about refractive index first. Warna hijau. Refractive index 1.66, refractive index 2.42. Okay, so this one will be 11.1 is smaller than 11.2. Okay, ini senang lah sebab kita nampak. Tapi optical density macam mana kita mau lihat? Okay, so we look at the refractive index. If the refractive index is high, the optical density is also high. Okay, so jawapannya juga adalah sama. The refractive index and the optical density, they're not the same thing, okay, but they have the same relationship. The bigger the refractive index, the bigger the optical density, which is the next answer. Okay, the bigger the refractive index, the bigger the optical density. Either way is fine. Okay, you can write it the other way, it's also okay. Relate the refractive index and the critical angle. The bigger the refractive index, the smaller the critical angle. Okay, ini ditunjukkan di sini. 2.42 besar, tapi critical angle-nya kecil. Okay, so This is how we will answer this. I think it's a very easy comparison and relationship. Okay, I'm telling this to all students, including mine. Do not waste this comparison and relationship question. Okay, spend some time, make sure that it's in your hands. Okay, uh, rainbow is basically spreading and refracting. Okay, sorry, it's not called spreading. What's it called? Dispersion. Dispersion and refraction. These are the two important principles of rainbow formation. Okay, but we have to mention that light enters the raindrop. Raindrop, right? Sorry, after rain. Okay, so raindrop. So when light, actually, you know what? Since you're talking about rainbow, it should be white light. Okay, when white light enters the raindrop, okay, the light is refracted and dispersed to different colors. Okay, all the dispersed light. Okay, all the dispersed light experience total internal reflection at the surface of the water. Sorry, at the surface of the raindrop. Okay, the light, sorry, the refracted light. The reflected light experiences refraction and dispersion again when moving or propagating from water to air. Okay, so the rainbow colors are observed in, will be observed. Yeah, something like that lah. Wow, something like that. Okay, there's a lot of refraction and dispersion, and then at the same time there's total internal reflection. Okay, it's kind of an amazing thing lah. Okay, rainbow formation. Okay, just from one light entering this one, a lot of things happen. Okay, all right, let's move on to the last question. I think this is the last question of the night. Optical fiber. Oh no, optical fiber. Optical fiber, I have a lot of answers, but okay, let's give it a go. Structure of the optical fiber, yada yada, improve the effectiveness. Okay, so this is the answer that we don't want to put into the question. Kita tidak mahu letak jawapan to improve the effectiveness. Okay, state based on the number of optical fiber, one, characteristics of the material, and the characteristics of the inner core. Three things, but you have to give at least 5 points. Okay, so let's start with the first one. The number memang tidak boleh lah. Number of optical fiber, okay, is high. This one set. Okay, it's a set question. The point of optical fibers is to carry information, is to carry signal. Okay, is to carry data. So more signals, okay, can be carried. Dibawa, so carried lah. Okay, number of optical fibers is high, more signals can be carried. I think that's as much as you can say about this. So the rest of the points have to go to characteristics of the material, characteristics of the inner core. Okay, let's focus on the material first. Okay, so I'm going to change color for this. Material is blue color. Okay, so we will say low density. Okay, low density material. okay, of fiber optics. Okay, low density is less mass or lighter. Ini standard lah. Okay, another one is high flexibility. Okay, actually this answer is in the black book lah, guys. So high flexibility, the reason is easier to bend. Okay, so that it doesn't break easily lah. Dia senang lah, dia sangat lentur. Okay, another one is high purity. Okay, the material is high purity, so you say less loss of signal. Ya, less loss of signal lah, sebab dia high purity, tiada benda yang menghalang itu signal daripada tembus itu fiber optic. Okay, there's one in the black book one. It says what like in bundles, right? Okay, it should be in bundles. Yeah, I guess you can write lah. Okay, fiber optics will be grouped in bundles. Okay, the reason for this is the same. Okay, more signal lah. Okay, can be carried. Okay, I think we have enough points for this one. 4 points is enough. Let's talk about the inner core. Okay, point yang terakhir adalah the inner core. So I'm going to change this to green color for the inner core. The inner core generally is glass, yeah, high density material. Okay, so high density material for inner core. Okay, high density material usually is low critical angle. Low critical angle means total internal reflection can happen. Okay, so all the signal will be ping pong, ping pong, ping pong, ping pong, ping pong, then dia akan senang sampai lah. Okay, low critical angle, total internal reflection occurs easily. Okay, does it ask for type of material? No, just characteristics. Okay, I think we can just give the characteristics. I think it's totally fine. You can also say high apa itu, refractive index. Okay, inner core, high refractive index will give you the same thing, small critical angle, more total internal reflection. Okay, so I'm going to just repeat the answer over here. Another one, I think this is in the black book. I think it says this. The material, okay, is glass for the inner core. Glass for the inner core. Why? Because it has a high density, but we cannot say high density because it's on the left. Okay, so we give the same answer as before. Low critical angle or total internal reflection occurs easily. Okay, still sticking to the same principle yang kau tulis di sebelah kiri tidak boleh digunakan sebagai sebab. Okay, cannot be used as a reason untuk di sebelah kanan. Okay, be very wary of this. I think it's okay to write more than one. Okay, but just make sure that it is related. Dia ada kaitan dengan dia punya soalan. Okay, I think that's about it for today. Just to kind of give you like a couple of reminders. This one is especially for those who are studying under me. Okay, I think at this point, what you should be doing, this is my advice, what you should be doing is going through all the question papers that we have covered and also the questions that you yourself have done, either with your own tuition teacher or, on your own studying. Go through the questions, okay, look back at things that are difficult for you to remember and start memorizing them. Okay, when you practice the paper one, okay, after you've done the paper, go through every question, especially the questions that you've gotten wrong or the questions that you tembak. Okay, so usually I would like to mark down there lah. Okay, this question I'm confident about the answer. This question saya tembak saja, so saya tidak tahu dia punya jawapan. These two categories of questions are important. The ones that you got wrong, okay, review them again. And number two, the ones that you tembak, figure out why the answer is such. Okay, worst case scenario is kalau kau tidak faham lah dia punya jawapan kenapa, cuba ingat saja. Just remember, oh, the answer is like this. Okay, and then hopefully it comes out for your paper one or something similar comes out in your paper one on the 15th. Okay, then at least, oh ya lah, saya pernah ada jawab soalan ni. Tapi saya tidak tahu pun apa dia punya jawapan, kenapa. Tapi saya tahu jawapannya begini. Jadi saya ikut saja. Okay, it has happened before, it may happen again. And I hope it happens for you lah. Okay, so that you get every mark that you should get. Okay, but I think the most important one is paper 2. Okay, go and review the papers. Okay, you should not be reading so much of your reference books now. Just go through all the questions, look at the sample answers, look through your answers. Okay, and this is gonna sound kind of creepy, but somebody has told me it works before. So ever since then, I've always told people this. It's gonna sound very creepy lah, okay, but fine, if you can do with it what you want. But I've had people tell me that they remember the sound of my voice when they are answering the physics paper, and they remember that saya banyak membebel-bebel pasal ni, terus diorang time exam pun diorang ingat. Okay, so if it's a good thing for you, go ahead, remember the sound of my voice when you're sitting for the exam. Okay, and hopefully all my membebel-bebel for the past 2 years with all of you, okay, works off. So that you oh yeah, answer ada cakap pula pasal ni. Okay, so if it helps you to remember the sound of my voice, sure, do with it what you want lah. For those of you who are from other schools, thank you for joining us tonight. I don't know whether Nadia and Connie are still here, but if not, thank you for your support. But I wish you all the best, okay, for the 15. Please know that our prayers and our thoughts go with you. I know, as cringy as it sounds, it's true. Okay, our prayers and our thoughts go with you. Please, 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 please do the best that you can. Okay, you've got this actually. Okay, it's just somewhere inside your mind, you really have to get it. Okay, I hope for the best for all of you. Good luck for your physics lah.